did line of symmetry and axis of rotation. Now this is
Yes.
3D image and plane of symmetry. It would just resemble line, like the concept is same. We had a rectangle and we could draw two lines of symmetry, one vertical and one horizontal. Now this line would just turn into a plane if we would have a 3D object, let me say rectangular. So I can draw a plane if I just slice it off from this position and through the complete image. So left hand side and right hand side is equal. And second plane could have been this till the bottom of the same image. And the third plane would be horizontal. If I can make myself clear through this diagram. So basically I'm making a comparison. The 2D shape we had two. So it will be mostly one more because we have one horizontal. For example, if I draw an equilateral triangle, we will have three lines of symmetry. But if I draw a three-dimensional figure with the same triangle at top and at the base, now I would have three lines, three planes of symmetry, which would resemble these three lines. If I just slice it off and through downwards till complete bottom second line and third line. And the fourth one would be if I just come between this height and midway. If we slice this midway, we just grab a knife and slice it midway. So that is one more. So this is four planes of symmetry. Now planes of symmetry for this cube, if we have equal sides, this second side and third side, these are equal. So two are in front of you, already drawn, horizontal, then at this angle, and so on. There are more. So we can actually draw 9 planes for the cube. Remember that number if it ever comes in exam. Don't waste your time. That would be one, maximum 2 points. So that is 9. And axis of rotation in cube are 13. 13 axes and 9 planes. Okay, exercise 7.2, question number 1. How many planes of symmetry does this cuboid with 6? How many planes of symmetry does this cuboid with 6 rectangular faces have? So planes of symmetry were just discussed. So we have, this is 1, this is 2, and the third one in horizontal direction throughout. So it has 3 planes of symmetry. Question number 2. How many planes of symmetry do these prisms have? Try for question A part. How many planes of symmetry are there? Anyone?
sir, the A part has uh, section, the parts.
Sir, I don't think the airport has. Read
It
question
has
two.
Sir,
one plane of symmetry. Consider the plane as a knife.
Oh yeah, sir, you can do the other side and from here,
In
yeah.
this way, if I just slice
sir.
it off throughout the
Yes, sir,
shape,
yes, sir, yes, sir,
Yes.
we
yes,
will
sir,
have two shapes, one on this side and the other on
yes, sir.
back
And
and side of
one,
the,
and
and we don't
yes,
have
sir,
any other plane for this shape.
So for B, we'll do the same. We'll slice from the like
And how many planes do you think it will have?
from
uh,
one
One,
for
that's
B.
right. For C,
C will also have one.
think again, it has
Just
uh,
read the
the number is other than
two,
sir.
it has
If
two, yes.
one in the middle and one on the
Yeah, one this way
oh yeah,
and
and
one the
one
yes.
other.
the other way.
Yes, sir.
Question number three. Draw a diagram of a cube like the one before this exercise and draw a different plane of symmetry. How many planes of symmetry does a cube have? Okay. I just told you that we'll have 9 planes. Let me try and draw a better cube and show you 9 planes. Okay. So that's our cube. I'll try to draw less lines so it's not messed up. For example, we slice off from this position and the knife comes out at this position. This would be one plane. Or let's just draw it. We have different colors. That's one plane. And the second goes from this vertex, comes out of the other vertex. And at the back, it would just look like this. 2 planes. Same way, this starting side and this is the ending side. Third plane, similar way. This is the starting side, that is the exit for the knife. Till now, we've drawn 4 planes, all in diagonal, right? And let me number them as well so we don't mix them up. One, two, three, four. Now, fifth plane, I'm drawing it on the top like line of symmetry. This is the fifth one which will go down throughout. Fifth plane and sixth in horizontal direction, sixth plane, and 7 and 8 in diagonal. So this is 7 and this is 8. Are you with me till 8th count?
Yes, sir.
And the last ninth count is horizontal. So we have 9 planes. Similar way, if examiner would ever ask you about axis of rotation, we have 13 of them. Now, axis of rotation. If I just pierce my needle from this vertex and bring it out from this is 1. Then this is 2. This is 3. Fourth one enters from this point and leaves from that point. 4. Fifth, sixth, Seventh, 8 is this top and leaves at that bottom. And now 9 from the middle to the middle. 10th from left side to right side. 11th from front to back. And 12, this midpoint to this midpoint. And the last one, 13, this midpoint to this midpoint. So we have 13 axes of rotation and 9 planes. If the examiner ever asks you to draw, you would always ask for 1, 2, or 3. Other than that, whenever they ask you to count, just remember this number and don't waste your time for this particular question. Planes are 9 and axes are 13 for cube. Number 4. How many planes of symmetry does a hexagonal prism have? Have a look.
Sir, 3.
It is not 3.
No.
8.
7.
7. Oh, yeah. 7.
First of all, we have hexagon.
Yes.
So we have 6 lanes, lines of symmetry. 1, 2, 3, 4, 5, and 6. And these will go throughout till the back, making it a plane from line
Yes.
to plane. And this 7th one is midway. So we have 7 planes of symmetry. Question number 5. How many planes of symmetry does an octagonal prism have?
Nine.
That's right, 9. How many planes of symmetry does a prism have if its cross section is a regular polygon with even number of sides n? So if that's even, we just did 2. These were 6. So 6 plus 1 is 7. These were 8. 8 plus 1 is 9. So we will still have n plus 1 planes. Even if they were odd, for example, we talk about pentagon, we will still have 5 lines of symmetry. This is 1, this is 2, this is 3, 4, and 5. And if I just convert this into a 3D shape, then we will be having one more at this position. Number 7. How many planes of symmetry does a prism have if its cross section is a regular polygon with odd number of sides? So same, we just discussed that. That is again n plus 1. Number 8. Draw a pyramid with a square base so that the point of the pyramid is vertically above the center of the square base. Show any planes of symmetry by shading. Okay, that is a practice exercise. Square base at the top, pointed end. Now, how many planes of symmetry do you think this shape would have?
So it's pyramid में. One, two. So this will have one, two, two. Wait, no. One, two, four.
Or Haris, we would need your help. What do you think?
Two or four. Either.
Uh, sir, I think it has
Either two or four.
1, 2, 3.
Oh. So this will have
That is 4.
4, yeah.
Now
four. Yes,
consider
sir.
this line, red line,
Diagonals too.
and it would come up
Yes, sir.
through the center point,
Yes.
and again come up through the center, and it would stay symmetrical. So we have 4 planes, and if we have to just show it by shading, this is what we can do. For example, this was my pyramid. So I would just draw one plane and show that by shaded, and then another diagram, and then another. We show 4 different planes of symmetry. Number 9. The diagram shows the plane view and the side view of an object. Plane view or the top view. How many planes of symmetry does this object have? You need to have strong imagination.
Okay, so 4.
That's correct. It has 4 planes of symmetry. 1, 2, 3, and 4 throughout, up and down. How many planes of symmetry does a cylinder have?
1 and 2. 2, I mean.
I think you need to reconsider that.
Uh, Cylinder has 2. I mean. So doesn't it have 2 sides? 2 planes of symmetry.
This is more than 2.
And I think it has infinite number, because I don't know, like
Infinite.
infinite, yeah. Is that how?
Because the top point
So it's
crosses
a
the circle.
sphere, so it will have infinite.
So circle would have infinite
Infinite.
Oh,
planes. I would love to say infinite plus 1, but that would still stay infinite. And then describe the planes of symmetry, if any, of a cone. The cone looks like this.
also infinite.
Again, infinite. So we'll just describe them either by words or show them as one. The plane would slice through the top vertex and through the base of the cone.